Hi everyone, this is Emma from ClusterWare. In today's video, I'm going to be showing you how you can create a distributed NodeJS application in less than 10 minutes. In our example setup, we're going to use 3 servers. One server will be an application load balancer, distributing the traffic coming from the internet. The bottom 2 are going to be our application servers, running a sample NodeJS application. And each of the application servers is going to have 2 CPUs, so we'll maximise our server's utilisation by running a separate Node.js process on each core. For demo purposes, we're going to use a very simple Node.js application called Distributed Timer that spins up a HTTP server and responds with 3 values. The first, a counter, indicating the number of seconds from when the application process started. The next, a human-friendly representation of the above counter in the format of minutes and hours called duration. And the port on which the HTTP server is running to indicate which application instance is serving our request. We'll start by copying the repository URL that we'll later use in ClusterWare. And next, we'll sign into ClusterWare. Okay, so let's get into it. On the dashboard, you can see your existing clusters, or you can create a new one. I'll create a new cluster with a repository URL that I copied in the previous step. Now I'm going to onboard my 3 servers to ClusterWare. I have a terminal on the side to run any commands that will be required to run the servers. I'm going to name the first server app1, as this will be my first application server. I need to paste the host name, provide the username, and click Save. On the next screen, we have the instructions on how to onboard the server. It includes just 2 simple steps. The first is to SSH into the server. And the second is to allow ClusterWare to access the server. And that's all you need to do to onboard the server to ClusterWare. Now I'm just clicking Done to sync the status of the server with ClusterWare, which may take a few seconds. And you can also check the sync status in the section below the server name. And next, I'm going to onboard the second server. This time I'll name it app2, as this is my second application server. Provide the host name and the username and click Save, and follow the same steps as for the first server to allow ClusterWare to access it. And now I'm going to onboard my third server. This time I'll name it ALB, as this server will be the one used as an application load balancer. The other steps are pretty much the same as for the other servers. And lastly, I need to SSH into the server and authorize the access. Okay, great. So now that I have all 3 servers successfully onboarded to ClusterWare, we can install some software necessary for our sample application. First, I'm going to enable install mode on each server and wait a few seconds for ClusterWare to sync the software versions. Next, I'll install Node Version Manager onto app1 and app2 servers, since these are going to be our application servers running Node.js. Next, I'll install Node.js version 18 on app1 and app servers. And since we have Git pre-installed on both application servers, the last thing we'll need is to install PM2 Process Manager. On my application load balancing server, we'll need to install Nginx. Nginx requires admin privileges to install, so I need to provide the root password of this server. But naturally, once the installation is complete, the password will be discarded from ClusterWare. Okay, fantastic. So we have installed all the necessary software. So let's move on to the application service that allows us to run and monitor application instances. Here, we're going to add two applications. The first one will be hosted on the app1 server. I'll leave the app directory as default and set the number of instances to 2, since we planned our distributed application to use 2 CPU cores on each server. The second application will be hosted on the app2 server. I'm also leaving the app directory as default, and I'm also setting the number of instances as 2, but this time I'm going to use port 9000. Once the applications are created, ClusterWare will complain about the app directory not existing, which is to be expected. To fix this, we need to go to the Git tab. We're going to pull changes from the repository via HTTPS, so we can ignore the public key warning for now, as it's a public repository. I'm now going to click clone for each application in order to pull the code from the Git repository into the app directory on the server. You can also change the branch over here if you need to. Now I can go back to the status tab and once again sync the process manager status for all applications. Once the sync is complete, I can see that the Node modules folder doesn't exist, so I need to run an npm install for each application. You can also use npm CI for CI/CD reproducible deployments, or npm update if you need to update already installed dependencies. And now that the Node modules folder exists, I can start both apps. And once the start process is complete, I can see that there are 2 app instances running on both servers, on port 8000, 8001 on the first server, and 9000, 9001 respectively on the second server. We can now check that the application is actually running by visiting the app server 1 on port 8000 and app server 2 on port 9000 or 9001. And as you can see, the application instances are running fine. So we can now create an application load balancer to distribute the traffic between those apps. Okay, so in the load balancing service, I'm going to create one new load balancer. The load balancer will be hosted on a server named ALB, which I installed in Nginx earlier in the video. Leaving the rest as default so that the load balancer will be distributing the traffic between all 4 application instances that we just created in the previous step. I'm saving my settings and waiting for the initial application load balancer status to sync. And as we can see, the site is not enabled yet, and the application endpoints are not present in the config. So now I'm going to click Restart Load Balancer. To perform the restart, I need to provide the root password for the ALB server. If you're performing a lot of administrative tasks on the server, you can choose to remember the password locally in your browser. It will be discarded when you close the browser tab. Now that the site is enabled and both applications are present in the load balancer config. And that is all it takes to create the distributed application on your on-premise servers. So finally, we can click the load balancer link and see the app response served by the different applications behind the load balancer. I have a simple script that I'll run on the developer console that calls the load balancer endpoint every second so that you can see the response is served by different app instances. And as you can see, the load balancer distributes the traffic to applications running on different port numbers. Thank you so much for watching. Now you can go ahead and give it a try yourself by following the step-by-step guide I left in the description of the video. If you'd like to learn more, check out my other videos and learn how to scale, secure, optimize, and eliminate a single point of failure in your application. See you in the next episode. Bye.